Okay guys, I promised you I would definitely do this problem on a video. So here's linear systems part 2. Okay, when you look at this problem, there's two things that should stand out. Number one, there's fractions, right? Oh man, those can be scary, right? And number two, if you look carefully enough, we got things scrambled up. We got a y here, a 8x over there, and so on. So what we're going to do, guys, is we're going to do this with elimination method, but we're also going to get rid of those fractions. So first, let's start with the first equation. Okay, so I can approach this one of two ways, but you know what I'm going to do to be a little bit clever is how about we just simply add 8x to both sides. Now why would I add 8x to both sides? Notice with the 8x gone, 8 minus 8 is 0, I'm now left with just negative 24 equal to 8x plus 12y. Okay? And that's standard form, which we will rearrange a little bit further later in this video. Now, what about the second equation here? Well, this one has a 9 for denominator. That fraction has an 18. What is the common denominator between 9 and 18? Well, 9 divides into 18. So, the whole thing to understand here, guys, is the first thing we're going to do to get rid of our fractions is we're going to multiply the whole equation by the common denominator 18. Watch what happens here. 18 times 1 is 18. 18 times 5/9. Now I'm going to do a little old school over here. If I have 5/9 times 18, I could put it 18 over 1. And hopefully you can see right here, they cancel out to 2. 18 divided by 9 is 2. And 2 times 5 is 10. And of course, all I have is 1 in the denominator, right? So long story short, 18 times 5/9 here, guys, is going to be a plus 10y equal to 18 times negative 7/18. Now again, if I have negative 7/18 and I times by 18, hopefully you agree, 18s cancel each other out. 18 divided by 18 is 1. And I'm just left with negative 7 over 1, which is just simply negative 7x. So guys, I call this the fraction buster method, but it's a method I'm going to have to keep remembering to remind you of because it's very effective at times. Okay, so now guys, I'm going to go ahead to a new page and rearrange my equations a little bit further. So first, note the red equation. I'm just going to flip it around. I know I have 8x plus 12y equal to negative 24. All I did was, with the equals, I can flip sides, right? Left is right, right is left now. Now, what about the second equation here? I'm going to go ahead, guys, and minus 10y both sides. The idea is get rid of this y here, leave the number by itself, equal to our x and y's over here. So again, with a little bit of arrangement, I have negative 7x minus 10y equal to 18. And I'll just go and double check my work. Does everyone agree that's negative 7x? I did minus 10y both sides. Hence, negative 7x minus 10y. And then, of course, I have an 18 constant on the other side of the equals. And again, all I did was flip it around, so both equations now are in standard form. Now, the trick to this one now, guys, is I'm going to times this by 7, and I'm going to times this one by 8. And the reason why you're going to see when I'm done. Okay, so 7 times 8 is 56x. 7 times 12 is 84y. 7 times negative 24 is a negative 168. Again, you may want to use your calculator to do that one. Now let's do the 8. 8 times negative 7 is negative 56x. Hopefully you're seeing right here why we did that. 8 times negative 10 is negative 80y. And 8 times 18 is 144. Now guys, so why did I times by the 7 and 8? Because look right here. I made a 56 minus 56, which of course is 0. We call that again the elimination method because we actually eliminated x. Here, I have 84 minus 80, which is 4y, equal. Here, I have a negative 24. And once I divide by 4, I know y is negative 6. And now what I'm going to do is take the negative 6 and plug it into one of my original equations. I could have used either one of these two guys, or I could have used this one with fractions, heck no. Or I could have used that one right there. Okay, well, you know what? I'm going to go ahead and use this first one here in yellow. You could have used the red one, you could have used any of the other ones, but that one looks nice to me. So that's what I'm going to do. So here we go. I know I have again 8y plus, 8x. 8x plus 12y equal to negative 24. And we know that y is negative 6. So I'm going to put a negative 6 in for y. Let's see what we get. 8x. 12 times negative 6 is negative 72 equals negative 24. I'm going to add 72 to both sides. 8x equals 72 minus 24 is 48. Once I divide by 8, I know x is 6. So my solution, guys, is x6, y negative 6. Okay? Now, guys, this video is the ultimate video in a way because it has several different methods that we utilized. Okay? Just for summarizing here, we started out here, and boy, it sure looks messy now. But we rearranged both equations, correct? We made sure they were both in standard form as shown in yellow and red. In the process, we also took the second equation here and times it by 18, because that's a neat trick. You times by the common denominator, that's how you can get rid of all your fractions. And that's actually what we did first with that before we rearranged it. And then on this page, here is the real elimination method comes into effect. I end up timesing by the 7 and the 8, knowing that I was going to get 56 minus 56x, and therefore eliminate the x, and therefore I could solve for y, and go on from there. Guys, this is definitely one video you ought to study, maybe make notes out of, reference it again in the future. Okay? But hopefully you now understand how to solve linear systems better. And I'll see you in class. Bye.